DNA, nucleic acids. This is where we are. What we've been talking about, and generally when people talk about DNA, is they talk about a form of DNA that they don't really always identify it as that. There are a total of three different forms. There's A, B, and Z form. Now, these forms vary a little bit. If you look at these three structures, this one, and this one of them probably looks a little bit more familiar than the others. And one of them looks like maybe the form that you've seen, the double helix that we looked at just a little while ago. And you'd absolutely be right to think that it is indeed B form. So B form DNA is kind of the biologically relevant and important form of DNA. A form and B form kind of interconvert between one another. A and B form are both considered to be right-handed helices. What that means is that they rotate along, as your hand goes up the helix, it folds in as your right hand folds towards you. Z goes in the opposite direction. Z is the third form of DNA, and this is a left-handed helix. Now, if we compare A and B DNA, those are the ones that I think are best and most valuable to compare to one another. The reason for that is you could kind of think about A form DNA as simply being B form DNA under low humidity or low humidity conditions. Now, the diameter of B and A form, well, it's almost 2.5 nanometers for both of them. They're comparable to one another. The difference between them ultimately becomes, well, how condensed they are. The rise per base pair, what that means is basically the height per base pair. A form DNA is a little bit more condensed. And we see that with the rise per base pair. The distance per complete turn, well, it's 3.4 nanometers for B form DNA. It's 3.2 nanometers for A form DNA. The number of base pairs per complete turn, 10 for B form DNA, where it's 11 for A form DNA. Now, these two forms, A and B, I always kind of think about B as your hydrated or your normal form of DNA, whereas A is that normal form with less water or in a dehydrated environment. Last but not least, the Z form DNA. Z form DNA is left-handed. Z form DNA, well, its helical diameter is 1.4 nanometers. Its rise per pitch or per base pair is 0.37 nanometers. Distance per complete turn is 4.5. So it's a little bit more extended. One of the other important components of Z form DNA is that this has a pattern. It's going to always have a purine adenine, purine adenine, purine adenine. So A and B form DNA are not going to freely interconvert from B to Z or A to Z. In order for that to happen, there would have to be changes in the sequence of DNA. So Z form DNA is something that would occur under, or it's going to be coded differently than A and B form DNA. So A and B are your most common forms. The B is kind of the most physiologically relevant form. Under dehydrated conditions, A form exists. All right. I hope that was helpful for A, B, and Z form DNA.